Okay, for this video I just want to talk about a couple more examples of distance and displacement problems that you could have that involve changes in direction. Again, if it's a straight line, the number is the same. It doesn't matter. The distance is the same as the displacement. The only difference is that with the displacement you would also include the direction. So I want to do these two problems and we'll start with this one, but I'll move to the notes to do them. Alright, so here's our two problems. The first one, a car moves 65 kilometers due east and then 45 kilometers due west. We want to know the car's distance and the car's displacement. So it's important to read these carefully, and all the problems where you see distance and displacement, it's really important to draw a picture. It really helps you to see what's going on. Because 65 kilometers due east is fairly easy, but a lot of people will read this very quickly and they'll just draw a triangle, kind of like the triangle that we drew here on this one. They're thinking about triangles and they think, oh, they're all triangles. Well, they're not. This one is definitely a triangle. These are two other types of problems you'll have, and if you notice, due west is actually back the other way. In case you don't remember, some people actually, some people have trouble with cardinal directions, and that's okay. There's our cardinal directions. I think some people just kind of forget sometimes. So east is usually to the right. So we go 65 kilometers east, and then from that point he comes back, not quite all the way, 45 kilometers due west, the other direction. As far as his distance, with the distance, no matter if it's a triangle or this one or another type, for distance we just add up all the segments. Doesn't matter what they are, doesn't matter about the direction change. 45 plus 65 gives us 110 kilometers. And we don't report direction with distance because there was a direction change, and distance is a scalar quantity after all, and we'll talk about that in the next video. But the displacement, remember the definition of displacement is, and you should have wrote it down here, of course that wording changed, the straight line distance from the beginning to the end of the trip. And when you do that, it's very easy to see from the beginning to the end. That's this distance here. To get that, we would take 65 and subtract the 45 from it. So the displacement is 20. 65 minus 45 is 20. Our unit we need is kilometers. And with displacement, we always report direction. Two ways to find the direction. From beginning to the end gives us that direction, and it is to the east. But another way to think about it is that at this point where he ends up here, he is right now 20 kilometers to the east of the point where he started from. Or she or this car, we didn't actually say who's in this car, maybe it's a car by itself, who knows. But the displacement is 20 kilometers to the east of the starting point. Alright, so that's another type of problem. So you could have a triangle, Pythagorean theorem. You could have a straight line problem, just forward and backwards, where we're just adding and subtracting, that's it. And keep in mind, these could be, you could have multiple legs of this trip, as long as you draw the picture carefully, you should be okay. And speaking of drawing a picture carefully, it's really, really important on this one. So we got this guy, his name is Ned Naylor, really cool name, and he walks 5 blocks north, 7 blocks east, then 8 blocks south, then 3 west, and then 3 north. And then we want to find out his distance and his displacement. You almost can't get this one without drawing a picture, especially for the displacement. So I'm going to start out going 5 blocks north, and then he goes 7 to the east, and the 7's got to be longer than the 5. Very important that we draw this picture to scale. So there's a 7 that's longer than the 5. And then he goes 8 blocks south from that point. The 8 has to be longer still than the 7, probably something like that. And then he's going to go 3 to the west from there, so I'm going to say 3 is something like that. And then 3 north from that point, and that is going to be something like that. Pretty proud of myself actually for drawing that picture. So distance, we just add them up. 5 and 7 is 12, plus 8 is 20, plus 3 is 23, plus 3 is 26. His distance he walked was 26 blocks. Displacement. Second question. Displacement, once again, if you know this definition, you can't get it wrong. It's the straight line distance and the direction from the beginning to the end of the trip. And if you drew your picture carefully, you'll see that from the beginning to the end is actually a straight horizontal line, which makes this a lot easier. So you'll notice that he walks 7 over this way. So this geometrical shape that we just drew is 7 wide, came back in 3. So 7 minus 3 is 4 blocks. So our displacement here is 4 blocks. And again, the direction from the beginning to the end tells us it's to the east. And that also means that at this point, he is 4 blocks to the east of where he started out. So for our displacement, we would just say 4 blocks east. So those are the 3 types of distance displacement problems you could have. Triangles, forward and backwards, which is just adding and subtracting. Triangle is Pythagorean theorem. And then you could have sort of random geometric figures like this. And this one's probably on the hard end of those. But if you draw the picture carefully, you shouldn't have a problem with it. So that's distance and displacement.